Okay, at this point, we're going to get into some stuff that gets a little bit deep. You don't have to understand how all of this works. You just have to know that it does. We're going to do pitch shifting. So I can get rid of quite a bit of stuff here. In fact, nearly all of it is going to get blown away, except for my K slider, my dry wet, and a couple other things. And I'm going to rename everything to PS out, partly because it stands for pitch shifter, and partly because it stands for PlayStation, and currently being socially distanced from work, I have a lot of video game time. Anyway, with my K slider, I'm going to give that a load mess to give it an initial value of 60, which is middle C. That's important because I'm going to use that value as sort of the basis for everything here. The other thing that is going to be really useful with that K slider is I'm going to use it to smoothly change the transposition factor. Now, let me show you how I'm going to do that. To make it smooth, I'm going to use line. And line interpolates from an initial value over a specified grain of time. This is going to be 20 milliseconds. I'm going to do that just so I don't have any harsh pops. It's going to still be really quick, but it doesn't have to be, super, super, super accurate. Move that over a little bit. Next, I'm going to take that value. I'm going to store it into an F. So F is just a float, and it's going to store a decimal number. The value coming out of line is a decimal, in fact. That's important if you wanted to maybe, say, interject something in between here, like O plus 0.5 or 0.25 to get microtonal stuff in there. And then what's going to happen here is I'm going to create a new live.dial, which is going to have some interesting stuff on it. So unit style, it says time millisecond, no thank you. I'm going to do MIDI note. And that means I'm going to have to do 0 to 127. Now, 0 to 127 means I get the MIDI notes that you would expect on a keyboard. If I give it an initial value enable, I'm going to set that to 60. And then if I hit delete, it pops to C3. So what I'm going to use this for, I will label it as root key. This is going to be my root tuning. So middle C. And then this K slider is going to be what I transpose to. Pretty cool stuff. Now, with this root key, if I go up a half step, it should get higher by a half step. If I go lower by a half step, it will get lower by a half step. If I go up a tritone, it will transpose up a tritone. Down an octave, it will transpose down an octave. I'm keeping this kind of limited just because I don't want to get too far out into the destroying your subwoofer or annoying your dog territory. Now, what I'm going to do here is to create a trigger object. I'm going to do trigger bang float. So this is going to receive a value. In this case, it's an integer, but float will work as well, from the live.dial. Then it will send that out as a float out of the rightmost outlet. It's also going to send a bang out, which I'm going to use to output the value that's stored in this float. Next, let's have that go to another line, 0.20. That's where the float's going to go. And again, this is just going to create a smooth line so that I don't have any weird pops. It's just something I noticed when I did this that it helps. Now together, those are going to go into a minus 60 point. This is going to subtract whatever is coming out of this transposition from the K slider from this line. So doing that is going to create a value. And that value is probably going to be just a really crazy decimal that could be whole numbers, could be decimals. It doesn't really matter. Again, you can insert things like plus 0.5, plus 0.125, whatever, if you want to go microtonal. But doing it this way, keep everything as a float for now. And the reason for that is that that is going to go to a trans ratio subpatch that is built into the path in Max. If I open that up, it says the M to F object works well for converting MIDI style pitches to frequency. For sample playback, one needs the transposition speed ratio rather than frequency. We're not actually dealing with speed, but we kind of are, because this is going to go and control a fast Fourier transform subpatch called Gizmo. I'm going to put a floating point out here, and I'll make it nice and big so you can see the decimals as we do this. So root key 60, transpose 2, 60 is 1. Up here we get all these really, really fine decimals coming out of trans ratio. Good stuff. Now, with Gizmo and Fourier transforms, that's something we won't even talk about a whole lot in class. That really is the advanced class. This is just the basic one. But suffice to say that what happens is you need to create a PFFT, which is a poly spectral processing manager for FFTs. And we're going to give it an argument. And in this case, we're going to do gizmo underscore load me, which is built into the Cycling 74 path. It's included with Max. And then we have to give it a FFT size. This is how many samples in integers are going to be part of every window. And that is 4096. And then the overlap factor of how many to do, we'll do 4. If you really want to get into the weeds on this, by all means, take a look. It's fascinating. But before you do that, you're going to want to read Miller Puckett's book, The Theory and Technique of Electronic Music. I believe it is all of chapter 9. Anyway, what we're going to do is connect stuff up at this point. So this is just going to come out here. And actually, I don't even need this one. We can get rid of that. We're just going to connect it up there, like so. And that will give me my default. But before I do anything else, I need to connect my signal into the PFFT. Now, if I take this all the way down, you're going to hear good old Anton.wave. Okay. One last thing I have to do. I do have to connect trans ratio into that PFFT. Forgot about that. There we go. And we're going to give it its default values so that it has the correct thing going into it. Now we're going to amp up only the wet signal. And there you have it. Simple transposition. If you really, really, really want to get into this in the weeds, you can double click to open PFFT and take a look at what's going on in Gizmo. It's frequency domain pitch shifter for PFFT, and it tells you how it works. But before that, again, you need to understand how the fast Fourier transform works and how to use that with PFFT, which really is my advanced class.